Is Kay Ayala here to present my visualization project. This project is of a bunch of data about the fires in California between 2000 and 2018. I would have done it for 2019, but the data set that I was looking at didn't have this year published, and it's probably just because the year's not over yet. So as you can see here, I have my three separate visualizations, and where to begin? Let's look at the fire map. So as you can see, there are little points on this map, and those represent the center points of the California fires, not the total land covered by each fire. They're a little small, but they're there. The ones in blue, as you can see by the legend down here, are currently power lines, and the ones in orange are all other fires in the year, which this year that is being displayed right now is 2018. Okay, next, let's look at the year chart over here on the left. The year chart displays the number of fires in a given year by the kind of cause. So this is power lines by year. So, for instance, there were 20 power line fires in 2000 and just over 30 power line fires in 2018. But if I click another column, it's going to change my other visualizations. So now if we go back and look at the map, our map has changed. And now everything is in reference to 2017. So there you go. And then if we go down here to the causes chart, what we see are the different causes in that year. Now there'll be different number of causes per year because some years there just weren't certain causes. And right now you can see that power lines is highlighted at 5.1%, but we can change this. So it looks like there were a lot of lightning fires in 2017. So I click on that. They were 22.1%, it looks like. And if we go back over here, we can zoom around on this map and see that a lot of these are located. This band up here is the mountains. So up here, there's another mountain range here and more up here. So largely lightning in the mountains. And then over here, we can see that there were a lot of lightning strikes in 2008. So let's go click on that and explore what we have going. So there were a ton up here in Northern California and not so many down here in Southern California. And none on the islands. There you go. Oh man. Okay, so lightning took up 57.3% of the fires in 2008. Unknown is the next largest at 10%. And strangely enough, it looks like we have some interesting causes of fires in here, like aircraft seemingly can cause fires, as can equipment use. There are more sensical ones like campfires, playing with fire, arson. That makes sense to me. So this is something that people can definitely play around with and find different insights just by exploring the affordances of the visualization. So I think that's enough about the appearance and the interactivity of the visualization itself. When the cause changes, it changes the map and the year chart. When the year chart changes, it changes the cause chart and the fire map. The fire map does not cause the year chart or the causes chart to change. Okay, so let's take a look at the code. I'm going to stop the code now just because I don't want my computer to melt. So causes chart is here. I have all of my attributes, my constructor, my setters and getters, and I also have updates in here, which I would consider to be the same as setting. Methods, a draw method, and then all the things used to draw the chart or make changes to the drawing itself. And then down here at the bottom I have my mouse clicked function. So my three visualizations here are named by what they contain. So we have the causes chart, the fire map, and the year chart. Each of these is structured similarly, where I have my attributes, my constructors, my methods, including my draw function. So there's that. And then same thing with year chart and draw function, drawing titles, drawing data, and what to do when the mouse is clicked. So that's all the views. And then the views talk to the controller. And so the controller is really where everything is happening and where everything starts from. So if we go over to my sort of main tab, which is called California Map, you'll just see this controller initialization. And once that is called, everything is run and controlled by this controller object. You'll see in here the creation of the different views is all done by the controller, and that's set up in part by the default constructor. That's where I have my papplet run. And then here's what happens if the user does something in year chart or if the user does something in causes chart. In the year chart, what happens is the year chart responds to the click, talks to the controller then asks the model, which we'll get to in a second, for data, and then passes whatever data is needed by the different charts back to those charts. So it updates everything through this function here and does all the queries to model. And then the same thing happens down here in causes chart. So why don't we go take a look at the model, and kind of a lot is happening in this model here. There was a lot of data cleaning and data processing done to make this project possible. This is where all the data is loaded, all the data is sorted, modified, sorted, whatever, into P images, and those P images are then stored in a hash map dictionary object. Then let's see. When that's right. So when this controller here asks for data, it comes here, uses setters and getters to set whatever data needs to be set, usually setting the cause or the year to the current one, and then getting maps, getting statistics that are stored in these or float arrays, and the hash map. The hash map controls all of the fire map data. The int number of fires by year cause is all of the data for the year chart, and the float number of fires by year percent cause is all the data for the causes chart. So that then passes it all back to the controller, and the controller then uses setters and getters inside each of these views to set the data and then rerun the visualization to redraw everything. So that's all of the stuff for processing, but then we have all of the data cleaning steps, which I did in Python because I think doing this in processing would have been a nightmare. So here we have data cleaning county boundaries. So this data set was all stored as a shape file. So I had to go learn how to use shape files in order to do this project. And so this was extracting the list of counties and the boundaries from the United States complete county map to just the subset that I wanted, which ended up being just the boundaries of the outside of California and the islands off the edge of California itself. So you can see here little process visualizations of me extracting the data and then saving everything to a CSV. So you'll see in the processing model that everything, actually this does not touch processing yet. All of this data is then passed to this, which is the background image for California. Initially, this was going to be what I have here initialized as VHI, which is Vegetation Health Index. So that's not really a topographical map behind the fire visualization. It's an index of the health of the vegetation. And I was going to get it by year, but there was not time to add that in. And if I had the project as it is would have been much slower to load and much slower to run because it's a lot. It's a lot of data. So here's the vegetation health for this is California, but it's not subset out of the United States. So you're seeing all the surroundings as well. Here it is with the overlay of the boundary, and then here it is just subset within the boundary using polygons to do a spatial index here, or sorry, to find the points where it is within California, and then including the islands. And this is all then exported out to a CSV, and this data, without the boundary, just the VHI data, is used as the background image for the fire map. Now, okay, so now we have, this was going to be fire perimeters, but it's not, it's just fire center points because spatial indexing is something I have not learned yet and is difficult to do. All this is changing from different coordinate systems into other coordinate systems because the data wasn't stored as longitude and latitude. It was stored as some native index, which was different. Then I have making all the different layers of the fire map. So this is getting all of the points for all of the years by all of the causes that you then see in that fire map in processing. Getting all the causes, all the cause names, and then just repackaging all of this data into data sets. Now these data sets, all these CSVs, they're being printed down here, saved down here. Those are some fires right there in a visualization. Here are fires for the entire state. And here they all are for 2018. All of this data is then what is accessed by processing, which can be found in the data folder for processing inside the processing project, and all of the CSVs there. I've also included within the data folder some things that processing will not and cannot, as far as I know, run, and that is all of my Python work that I just showed you. So all of the data sets, the IPython notebooks, and the CSVs I generated between those different IPython notebooks. And there you go. That's my fire map visualization. I hope you enjoy it, and thank you for watching.